Okay, guys, let's look at the first worked example on this very law we're discussing today. Now, look at what we have. Show that carbon 4 oxide, which is CO2, and carbon 2 oxide obey the law of multiple proportion. Now, we talk about carbon 4 oxide and carbon 2 oxide. Now, look at what we have. Carbon 4 and carbon 2, oxide and oxide. So this oxide here is oxygen. When we talk about carbon 4 oxide, this is carbon having an oxidation number of 4, or valency of 4. Oxygen has a constant valency of 2. So by the time we bring this together, we've done this already in our previous lesson on how to write chemical compounds, chemical formulas. So that's going to be C2O4. So when we break this down, we have a CO2. So that's carbon 4 oxide. So sometimes we call it carbon dioxide. Carbon 4 oxide is the IUPAC name. Those are old name. So CO2. So next we have is carbon 2 oxide. Carbon 2 oxide. What do we have? We have C2O2. This takes out this. And then we have CO. This is carbon monoxide, the old name. The IUPAC name or the new name is carbon 2 oxide. Now, this two, how do we use this two to buttress or to show the law of multiple proportion? How do we use this to explain what John Dalton saw, while working on different atoms of elements? Now, this is it. Now, don't forget the law. The law we're talking about there is provided the various atoms of a given element combined with a fixed, mass of an atom of another element, to do so in a simple numeration. Now, they combine to form multiple compounds. Now, the first compound we have is carbon 4 oxide, which is different from carbon 2 oxide. They are entirely two different compounds. But carbon and oxygen, play huge roles in this in the derivation of these two chemical compounds. So look at the very first one is carbon 4. The next one is carbon 2. So how do we show that this law is going to obey? Now it's very simple. We look at the first is carbon 4. Let's say carbon 4 and carbon 2. By the time you check them, 4:2 is 2 here 1, 2 here 2, so it's just 2:1. This is a simple way to explain it. Carbon 4, carbon 2. So when you work on them, it's 2:1. But there's another way we can work on them. Because when you look at CO2, let's look at the atomic mass, the molecular mass of this. Carbon 4, look at carbon. Carbon was the atomic mass of carbon. Atomic mass of carbon is simply 12. Oxygen is 16. So when you look at CO2, what we really have here is this one atom, these two atoms. So what we have here is 12 grams of carbon plus 16 times 2 is 32 grams of oxygen. That's what we have for the CO2. And also for the CO, what we have here is 12 grams of carbon combining with 16 grams of oxygen. So as you can see, right here we have 12 grams of carbon plus 2 grams of oxygen, 12 grams of carbon plus 16 grams of oxygen. So even for the fact that we have different masses of carbon, as you can see right here on the board, yes, we have different masses of carbon, but after the whole reaction, we end up having different atoms of oxygen. Here, 2 atoms of oxygen, 1 atom of oxygen. So when you compare them, just like what we have here, carbon 4, carbon 2, 2:1, even oxygen 2 atoms, oxygen 1 atom is 2:1. So let's do another comparison. If you have 12 grams of carbon combining with 32 grams of oxygen, so we can assume that 1 gram of what? 1 gram of carbon will be what then? What's it going to be? If 12 grams of carbon combines with 32 grams of oxygen, then 1 gram of carbon is going to be S gram of oxygen. So that will be 32 divided by 12. Can use our calculator to do that. Let's quickly do that. So 32 divided by 12, that will give us 2.6666. That is 2.7 grams of oxygen. So that means if 12 grams of carbon can combine with 32 grams of oxygen, it means 1 gram of carbon we have to combine with 2.7 grams of oxygen. So let's do the same thing for this. If 12 grams of carbon can combine with 16 grams of oxygen, it means 1 gram of carbon will combine with what? That is 16 divided by 12. Let's do that right away. 16 divided by 12. That will give us 1.33333, and so on after 1.3 gram of oxygen. So if we look at this, 1 gram of carbon, 1 gram of carbon, they are both the same. So we compare the ratio of this. That was going to give us 2.7 grams of oxygen to ratio 1.3 grams of oxygen. So when we have a ratio of this 2.7 divided by 1.3, So what do we have? We have this 2.7 over 1.3. We end up having 2 ratio 1. This is what Dalton is talking about. As simple as that. So when the various masses of the various atoms of a given element, as we talk about an element with multiple oxidation numbers. When the atoms of this element combine with the fixed mass of another element, such as oxygen, oxygen just is constant. Oxygen is 16. There's nothing like oxygen 4, oxygen whatever. But if we have carbon 4, we have carbon 2. So for the fact that we have multiple, oxidation numbers for this very carbon combining with a fixed oxidation number of oxygen, this O combination, according to John Dalton, from his observation, he found out that this O combination happens in a simple whole number ratio. As simple as that. So that is everything for this very lesson. At this very point in time, we're drawing the conclusion on this very lesson. If you found this lesson helpful, I would love you to subscribe to this very channel at EduMosaic and also follow me at Revelation Hub on Facebook and share this lesson with others. See you in the next lesson. Thanks.